This video will be covering a fourth degree polynomial problem. The directions are to find the zeros of the polynomial, the complete factorization, and any other points you may have found. Let's take a look at our problem. Our problem is f of x equals negative 10x to the fourth power minus 11x to the third power plus 30x to the second power minus 7x minus 2. The first step we need to take in order to solve this problem is to find the p's and q's of the polynomial. Basically, we are reducing the number of possible zeros from infinity to just a few using the rational roots theorem. The p's and q's of a polynomial are just the factors of the constant, or the p, and the leading coefficient, or the q. We divide the p's by the q's and get our possible zeros from which we can use later in the problem. The next step is to use Descartes' rule of signs to give us an idea of what to expect from the zeros in terms of positives and negatives. There are three parts to this rule. The first is to count the number of sign changes, which will then equal to the amount of zeros in that given category. The second is that finding negative zeros requires the x value to be negative. To make this easier, all we need to remember is that even powers will have the same sign and odd powers will have a switch sign. The third part is to account for imaginary zeros, which always come in conjugate pairs. So once we get our number from our rule, we subtract 2 until we reach 0 or lower and use each subsequent value that we subtracted from. Remember, we cannot use negative values when accounting for zeros. The following step is using the information we know to find the actual zeros. We can take one of the zeros we found in our first step and use it in synthetic division to see if we are left with a remainder of 0. This would indicate that the number is in fact a 0 for the polynomial. Here we get lucky in choosing zeros and the first number we choose is a factor. We get lucky once again and the next number we choose when dividing into what we have left also gives us a 0. Once we have reduced the polynomial to just 3 terms, we can easily find the rest of the zeros by completing the square or using the quadratic formula. Here we should choose to use the quadratic formula because completing the square would be much more work. Once we solve the formula, we find that the last 2 zeros are in a messy radical. The last step is to write out our answers, and the easiest part is listing the zeros, which is just the numbers themselves with their multiplicity. The multiplicity is basically how many times a number shows up in the answer. The factorization can be done in 2 ways. If asked to show it in all real numbers form, this method should be used to keep the original 3-term polynomial that we put into the quadratic equation. One more thing to note here is because we took out a negative 2 from our small polynomial, we can take that 2 from our number and multiply it to the term with the fraction, just to make things look a little nicer. All that's left is that negative 1 that can go in front of our factorization. The other method is to use the radical 0 we found, and instead of leaving it like this, we can put the x over 10 and join these two together to make the answer look a little nicer. Once again, we do the same thing we did in the last step for the fraction. The final answer is any number we may have found during this problem, right over here. We can really only say we found our y-intercept because we substituted all of our x's as zeros and found that the y-intercept is negative 2. That's all for this video. Thank you for watching.